Hey students, today we're going to talk about graphing linear inequalities. Make sure that you take notes over this because we will be using these in class, and these are very good notes. So, the solution to a linear inequality in two variables involves a line and a shaded region. So it's going to involve a line and a shaded region. Okay? Now, the line forms the boundary of the region. So the line is going to form the boundary of the region. And the shaded region describes the solution area of the inequality. So it's going to describe the solution area of the inequality. Okay? Now, there are 3 steps. Okay, so these are our 3 steps. The first one is be sure the inequality is in slope-intercept form. Remember, slope-intercept form is y equals mx plus b. So slope-intercept form is y equals mx plus b. In order to graph, the equation must be in y equals. Y has to be alone. If y is not by itself, you cannot graph it. Okay? Then, graph the line using the y-intercept and slope. If it is a solid line, it's going to be a solid line if the inequality contains a line underneath. So if it's less than or equals to or greater than or equals to, it will be a solid line. It's a dotted line if there is no line underneath the inequality. Okay, so it would be a dashed line. So something like this, if there's no line. If there is a line underneath, it's just going to be a solid line. Okay? Determine which side of the line to shade by selecting a point to test on one side of the line. So you just need to test one point. So select a point to test on one side of the line. Plug into, so we're going to plug it into the original equation. Hint, it's a big hint. Use 0, 0 if it is not on the line. So use 0, 0 if it's not on the line. It makes everything so much easier. And if the statement is true, a true statement, you shade the region containing the point. If the statement is false, you shade the region not containing the point. Okay, so true statement, you're going to shade the region containing the point. False statement, you're going to shade the region not containing the point. You might need to pause the video, jot these notes down, and then continue watching the video. Okay, so now let's look. Graphing using slope and y-intercept. There are 6 steps for graphing using slope and y-intercept. So there are 6 steps. Step 1, rewrite the equation or inequality in slope-intercept form. So what is slope-intercept form again? You are right. It is y equals mx plus b. So if it is not written in slope-intercept form, you're going to rewrite it in slope-intercept form. Next step is to identify what the y-intercept is. Remember, y-intercept is going to be your b. So it's going to be the b. And then you're going to graph the y-intercept. So we're going to start with our b. Then you're going to identify the slope. Slope is going to be your m. Good job. Okay? And use the slope to plot more points. Start with the y-intercept and do rise over run. So you're going to start with the y-intercept. So we're going to start at b, and then we're going to do rise over run with our slope. And then you're going to draw a line through the points. Now, again, you may want to stop the video, jot this down, and then continue. So now, let's look at some examples. So we have y is less than or equal to 2x plus 3. So remember our steps. We're going to rewrite it into slope-intercept form. Is it already in y equals? Yes, y is already by itself. So I do not have to do step 1 in this case. The next one says to identify the y-intercept. So we're going to identify B. Well, remember the y-intercept is going to be the number that stands alone, stands by itself. So in this case, it's a positive 3. So my y-intercept is 3. Remember, we have to turn it into a point though. So to turn it into a point, it's going to be 0, 3. For the y-intercept, x is always 0. So now it says to graph the y. So we did that one. Now step 3 says graph the y-intercept. Well, we're going to graph this point, 0, 3. So I start at the origin and I go up 3. So there's 0, 3. Okay, so I did step 4. Step 5 says, oh, I'm sorry, I did step 3. I have not done step 4. Let me erase that real quick. So now, step 4 says identify the slope. So we need to pick out what our slope is. Well, remember your slope is always in front of x. The number in front of x is your slope. Okay, and this was our b. The number in front of x is always your slope. So my slope is 2. Now, so I identified the slope. Number 5 says use slope to plot more points. Start with the y-intercept and do rise over run. Now, in order to graph, your slope must be in a fraction. Okay, so in order for it to be in a fraction, to turn a whole number into a fraction, we put it over 1. So 2 is my rise, and 1 is my run. And if you notice, they're both positive. They are both positive numbers. So that means I'm going to go up. They're both positive. So that means I'm going to go up and to the right, because they're both positive. So from my y-intercept, I always start with the y-intercept. I'm going to go up 2, 1, 2, and then I'm going to go to the right 1. And that's where I'll put my next point. Then I do that again. I go up 2 and to the right 1. So then I just connect it. And I know that's not a very good line because I'm using a mouse and it's not very good. But then you would just connect them, and that would be your line. Uh-oh. I forgot. Now, for inequalities, though, we have to look to see if it's a solid line that we're connecting with or a dotted line that we're connecting with. So, since this has a line underneath, it is going to be a solid line. So I did it correctly. Now, we have to test which point because we have to shade. So, since if you look right here, 0, 0 was not on this line. So let's just use that point to test. So we're going to plug 0, 0 into y is less than or equal to 2x plus 3. So we're going to plug that in. Get a different color. So I'm going to put in 0 for y and 0 for x. So I have 0 is less than, sorry, 0 is less than or equal to 2 times 0 plus 3. Well, what's 2 times 0? It is 0, so that cancels, and so I'm left with 0 is less than or equal to 3. Is that a true statement? Yes, it is true. So since that is a true statement, I would shade all of this down here, because that is a true statement. Okay? Now let's go to the next one. We have y is greater than negative 2x divided by 3 plus 2. So again, we need to rewrite into slope-intercept form if it's not already. It is, so we can check that one off. Then it says identify your y-intercept. So what is my y-intercept in this case? You are correct. It is a positive 2. So this is my y-intercept. So if we turn that into a point, it's going to be 0, 2. So that one's checked. Then it says graph the y-intercept. So I'm going to graph 0, 2. So I'm going to start at the origin and go up to 2. Okay. The next one says, so that one's checked. The next one says identify the slope. So we need to determine what the slope is. Remember, your slope is always the number in front of x. So what's in front of x? Negative 2/3. So that is my slope. So my slope in this case is negative 2 divided by 3. Now, we're going to do, so we did that, sorry. Now number 5 says use the slope to plot more points. Start with the y-intercept and do rise over run. So we're going to do our rise divided by our run. Now if you notice, the 2 is negative. So since it is negative, we are going to go down first. And then the 3 is positive, so then we'll go to the right 3. Okay, so our signs tell us what direction we go. So let's do that. So it says go down, hold on. Okay, so I'm back. So now we're going to start at the y-intercept, and it tells us to go down 2, so we'll go down 2, and then to the right 3. 1, 2, 3. And then again, you go down 2, and then to the right 3. 1, 2, 3. And put a dot there. Now, before we can draw our line, we have to look at our inequality. Since there is not a line under our inequality, it's going to be a dashed line. So when I connect this, and again, it probably is not going to be perfect, it's going to be a dashed line. Okay? Now, we have to test to see where we have to shade. So again, if you notice 0, 0 is not on the line. So let's just use 0, 0 again. So I have the equation y is less than negative 2x divided by 3 plus, plus 2. So now we're just going to plug in. We're going to plug in 0 for x. We're going to plug in 0 for y. Sum of 0 is less than, greater than, I'm sorry. 0 is greater than 2 times 0 divided by 3 plus 2. Now, what's 2 times 0 divided by 3? That is going to be 0. Okay? So now it says 0 is greater than 2. Is that a true or a false statement? You're correct. It is a false statement. So, since it is false, you shade in the area that does not contain that point. So since this down here, we're going to shade above. So we'll shade all of this area. Okay? So that would be the area that we shaded. So if it's false, you shade on the opposite direction. If it's true, you shade that area. Okay? Next, last one. It says, which of the following ordered pairs are in the solution set of y is greater than or equal to 2x plus 3. So is what you're going to do is we take each one of these points and we test them. We take them and we substitute them. So if we do a first, this is a. So we have the equation, and now we're going to take 0, 0 and plug it in. So I'm going to take the ordered pair 0, 0 and plug it in. Sorry. So I'm going to put 0 into x and 0 into y. So when I do that, I'm going to get 0 is less than or equal to 2 times 0 plus 3. Now what's 2 times 0? It cancels, so I'm left with 0 is less than or equal to 3. Is that a true statement? Yes. So that is part of the solution. Okay? But now we got to try B too. So let's do B. So we're going to take the point -1, 0. And we're going to plug those in. So -1 is going to go into x, and 0 is going to go into y. So I have 0 is less than or equal to 2 times -1 plus 3. So 2 times negative 1 gives me negative 2. Negative 2 plus 3 is 1. So 0 less than or